Okay, I think we can get started.
Yeah, we are live.
All right. So, yeah, good evening, good morning, wherever you are. We are actually starting off with the sixth session for a certified Meshery contributor study group. If you had been following the series, you might be aware that in the previous session, we actually did a coverage of theoretical um, we did a theoretical coverage of measuring models, and in this session, we are going to actually continue with the practical hands-on. And we are thinking of going through creating a model via the playground and then via Meshery CTL. We'll look at the packaging of the models and then Meshery policy engine and some practice questions as well. So, uh, when it comes to creating models. Meshery offers like two ways to create models. One is actually to use the create tab, create button that you have in the canvas to create models, or you can actually do an import also if you have a OCI compliant um, image, which is actually a tar file. You can actually import that, or if you have a model definition file in a CSV or JSON format, you can actually use that. Create is, you can actually use that if you have something in your mind, but you don't have the related files to create. You just start with create, and you can always export or re-import your models later. So, we'll be actually looking at how to cover this in UI. Um, sorry. Um, Inside the dashboard, you'll actually go to the canvas and sorry, here inside. First thing is like this canvas will be actually used to use the models and use the components and all to create your design. First thing is actually you go to registry. This is the place where you have all the models and everything registered. You can see how many components and registrants are actually there. Registrants is nothing but you have something like a artifact hub or a GitHub where you have the CRDs definitions. You can actually import from there. And models, you can actually do create model or import model. In create model, first thing is actually you have a dialog open when you click on create model. Here you need to actually enter the model name. Model name should be actually unique name with the hyphens and not white spaces. And model display name can be actually including letters and numbers and spaces. In case of model display name, you cannot actually add special characters over there. So there is something you can note as you go here. You need a source URL. So there is this integration spreadsheet which you can use. This spreadsheet contains multiple sections as to models, components, relationships, categories, and all those stuff. So we can actually refer to this one to create the model that we want to create. Simple one would be Azure's. Sorry, let's actually try to see simple storage AWS S3. Let us actually try to see. And here you can actually see the CRD. Oh no, this is actually going to be complex. So let's actually try to see a simple one with the cert manager. This one. Let's actually try to see how to take it. Instead of Artifact Hub, let's actually go to GitHub. This is the place where you have deploy CRDs. You go to HTTP, you can, oh no, sorry. Uh, uh, github.com certified. Okay, let's actually just use this one because this is a Git URL. You can actually use that there in the dialog that is coming up in Canvas. Let's actually put it as cert manager, test, model display name, test cert manager model, because I tried it before and it's showing me this. Next part is actually like you can actually add the appropriate category and subcategory. So in this particular integration, the thing it is given as um, GitHub as provisioning and subcategory as key management service. Let's actually use the same uh, provisioning key management. Okay. Next, we will actually use a logo for dark theme and light theme if you have. If nothing is actually used, Meshery will use the default values. And primary color and secondary color, we can take something which you like. And then shape, let's actually try to use a rhomboid. Next, please identify the location from which you need to source your models component. So in case of Cert Manager, it's available both in Artifact Hub and GitHub. So we will be using the GitHub URL, this one. And next, additional details. It's actually used when you are actually adding a model, which is supposed to be only annotations, like shapes, for instance. Then we will be checking this checkbox. Since we are actually creating a model which is based on the CRD of Cert Manager, we will not actually check that. And in the next page, um, finalize generation, you get the model summary. If you think that you made some wrong entries, you can always use this back button to um, uh, so the next part is actually generation of the model. You click on generate, registering model, you can actually see that. So yeah, so you can actually look into the registry tab and then see that this has been added. It'll take a while.
We can't hear you, Kavita.
Oh, sorry. Yeah, I think if I go to settings and go to registry and search for the model, search manager test. Yeah, you can actually see that it's available here. Model is v1.2.0 alpha components and then relationships. One second, let me actually try to find out. You go here, deploy, and go to the CRDs. You can actually find out the YAMLs that are actually available. So 1, 2, 3, 4, 5, 6. You can go into settings, 6 components created according to the YAML, CRD YAMLs that are actually available. And it has actually fetched the v1.21.0 alpha from the latest release that has happened over there. So there is actually no relationships inside the table. Also, if you search for search manager in the relationships, you will not get anything. You can actually create ones over there. And one of the things which I wanted to actually point out during this session was that we have something called a Meshery catalog. Meshery IO catalog. If you go there, you can actually see the well-architected Kubernetes designs that I mean, you can actually even go and then publish your best practices or learn with the team and share your findings so that it can be used. So, uh, in case of designs, these are actually 351 designs are there. You can select sort by name or select by categories and then select your designs and see the models also that are actually available. That is possible. And we have seen how to create a um, create a model using create in Canvas. So let's actually try to see how to import a model. The same one you can actually export. Okay, and we can actually say that if there is obviously when we are trying things from the uh, sheet, we will be having duplicates. So it's you need to note that in case of Meshery, if you check the Meshery model command also, there is actually nothing called delete. It's always update, create. But you can actually ignore, but there is actually no functionality called delete a particular model. So if you actually click on ignored, it will not be actually available for you. So we did the export. It got downloaded as cert manager test.rar, and I can actually just do the import. In case of importing a model, you can do a URL. If you have a URL in GitHub where you have the model files defined, you can use that URL here, or you can use a file import or use a CSV import. CSV should be having the topics or columns that are actually similar to what we have here. Due to lack of time, we are not going to look into everything like creating a model from the CSV fully, but I'm just showing how it should be. It's very much possible for us to create custom models using the CSVs. Um, so we will just try to reuse the same model and then see what is happening there. Cert manager, it has been actually added. Now it is actually going to register the model. It got added. Finish. And then if you search for cert manager again, test, it should be actually available. If you see this alpha, um, maybe the components will become 12. That's because I had this the component, and this was actually enabled earlier, and then you did an import again. So it's actually the same thing being imported and again. So it is actually just doubling the component instance of the components that we have. Um, so this is about the model creation um inside I mean inside UI, which I wanted to cover. Next, we will actually look at the CLI. Here, I have actually built the CLI um, using the latest one, which I had. I think I just have to, just a second. I just have to sync my branch to the latest so that we work on what is there in the upstream. Just a second, bear with me. As I told earlier in the first session, we will use make, and it should actually build the latest code. Just to uh, ensure that we have the latest one. So yeah, Meshery CTL system start minus p right open. Yeah. So that is this one. It'll just take a while to show, but yeah. Let's ensure that we have everything in place by using system check. We have the Meshery server running it. Wait, CLI. Let's actually ignore that. Um, we have something called in Meshery CTL. As I told you earlier, you can do a dash dash help for each of the subcommands and then see. So Meshery CTL model init is the subcommand. Um, Previously, this init was an experimental command, and sorry, model was an experimental command, and it came out of the exp. So If you look at the documentation, some places it would be actually telling like Meshery CTL EXP model in it, for instance. That is just because that we have just evolved the code, and maybe we actually missed some places to update. Um, Help. You just have to give the model name, say ABC, and then it will actually give you run you through the the how to create. It's a kind of a scaffolding. Um, so you have pre ABC. If you see, these are the starter files that actually got created using the model in it. This is actually helpful, particularly when you have an idea about the model that has to be created, but still you don't know like how the folder structure should be there. So with Meshery you can actually get this created, and then what you need to do is just edit these files to include your definitions of relationships or adding your components there, and then use the Meshery model build to do that in your local. I am not sure whether I should actually show that here, because it will be like kind of time consuming, and we have just 1 hour slot. Half an hour is already over. So I would actually leave this part at this level so that you can go further after the call. You can go further and then explore how to work with the Mesh CTL for creating the model. So yeah, after you actually do everything, you can do model build, and if you have a file, JSON file or a CSV, you can actually use this model generate. You have you can actually list the registered models. You can search for the models, and we can actually view a particular model with using all these subcommands. And export is again used for creating, exporting the OCA compliant package that you use with the build for part here. You can actually use that for exporting into a tarball and then import that inside the UI or the CLI. So that's the thing. Um, I can actually move to another thing in Canvas. So we actually spoke about many things that can be imported or cloned. So this is one of the designs which was created by Himani. I just imported it. Um, you can actually use new from a template, and then use any of the you actually get the templates from the Meshery catalog. There are official ones, there are verified ones, and then there are community built ones. You can actually select one of these, and then you know uh, use it. So here you if you click on one of the catalogs, you can understand understand what is actually available there, and then use clone so that you can actually check. So this one I actually used in particular because some people might be actually trying, and uh, the design might not be complete, but they just export it just for understanding and all. But this looks pretty okay for me to show. Um, so Hmm. To show how imports and exports, importing the design and or cloning the design actually works. So this is just about canary deployment. You have canary web and the primary web deployments, services related to that, and then ingress. And then in canary, what happens is that you actually have um, the traffic rule defined such that you have X percentage and 100 minus X percentage going into these two. So this is one of the ways in which designs can be actually used. And once you are creating your design, you have actions like validate. It'll check whether you have actually defined it in a structured way. It's possible to do a dry run, and if you are actually using playground and then connecting it on to your custom environment, you can actually do it like deployment using the deploy. This is actually used for undeploying, that is actually to withdraw the deployment and or make that deployment invalid. So this is one way in which you can further explore Canvas. um, let's actually look into uh, the slides that are available just to see whether we covered everything. I'll just yeah, this is the model builder wizard which I showed you. That's actually available inside the canvas when we created the model. So it's actually kind of intelligent component generation is supported, and it's possible to use both annotation only or fully semantic. We saw the checkbox over there. Inside, yeah, Meshery model in it is actually used to create the skeletal structure or the scaffolding folders where you can customize by editing those files. Import model brings your model into the Meshery, and export actually creates your OCI image for the distribution. Um, yeah. So next is actually about packaging your models. The main thing that you need to ensure is that it's better, it's easier for everybody when you make your models portable, reusable, and easy to distribute. OCE models can be actually packaged as OCI images. um, you can actually even have the models exported, I mean the URL for the source can be actually from many of the OCA compatible places. You can actually even have them from Docker Hub. um, and It's should published into the catalog for other people to use, and if you want to actually share it with your teammates or colleagues who are actually exploring machine, that can be actually used there. Each model, as you saw, is version aware. If you go to here, sorry, you go to the settings and then search for example, Azure, Azure. There are there are models in which you will be having multiple versions. Mm. Um, yeah, I think it was session storage. I saw one which had multiple versions imported. So it's possible to have multiple versions over there, but that will be actually defined using this particular version value, API version value. Yeah. So and its models can be packaged and transported across the teams and platforms to ensure consistency, deployment, and collaboration. As I told earlier, it's easier to visualize your cloud native infrastructure using the models, and Canvas actually gives you a very good way of seeing that in UI, and then you can actually it is much more easier rather than just working with the YAML files. I think with that I have completed all the topics that I wanted to cover, and over to you, Ronak, for Meshery Policy Engine.
Yeah, thanks, Kavita, for briefing us about how to import and export models. And so now we'll be, since we covered some of the theoretical part of what are policies and what is OPA and what, so Mishri has a built-in policy engine based on Opa. So I'll be just giving a quick recap of what we covered in the previous session, and then we can move on to some of the hands-on stuff. So, um, OPA is a general policy engine that unifies the policy enforcement across your project. So it decouples the policy decision making from policy enforcement. So here's a nice example over here that rather than enforcing the logic of writing your policies in your code, you just write policies and let OPA evaluate. So you write them in Rego, and that's how a flow of it is that a client sends a request to the service, then that service queries the OPA with that payload. And then since you have some of the Rego policies written, so it's a declarative way of writing Rego policies. So there's one thing called as declarative and another thing called as imperative. So in declarative, you don't specify how that thing is done. You let OPA decide how that thing is done, and you just mention what needs to be enforced in the Rego policies, and that's how OPA will evaluate, and it will just return the response back to the service, and the output can be like an arbitrary data rather than like simple yes or no answers. So it supports much more than that. But there's a continuous effort as well going over porting from the open policy agent to native Golang, and there are multiple reasons for that. So we'll be also covering that. But let's currently understand of how um things work and how evaluations work in Meshery. So, for example, if I go to Canvas and over here, if I take a component, let's say deployment. So as soon as I uh, drag this over here, so automatically, as you can see over here, I am the deployment uh, has a parent namespace, and that's the default namespace. I didn't added that component; it automatically got added, and this is because of this Meshery evaluation engine due to this thing. So as you can see, this icon. So whenever this spins up, so this Meshery UI that is a client, it just takes this YAML document and YAML or JSON whatever, and then that sends this design to the Meshery server, and then the Meshery server evaluates that what relationships needs to be performed based upon the rules or Rego policies that have been written. And we use like Rego policies not just for defining rules in designs and relationships, but more than that. So the Meshery server is like, okay, I got a deployment, and it should be in a namespace because that's how Kubernetes works and everything. So it will just return back the design document and adding another component as namespace, and then this will sync data over. So that's a round trip that happens each time you modify the design document. So, for example, let's say if we have another component as a, for example, service. So as soon as I add this, it will automatically be configured in the same namespace due to this thing ran again, and it will evaluating relationships, sending the design document back to the Meshy server, and that's how. So if I try to establish manually a relationship between the deployment and the service, so for example, as you can see, whenever I take this arrow, so the opacity of the design is reduced. So that's this thing over here that is happening, that is running another evaluation engine that is running on JavaScript on the browser. So we have two evaluation engines currently, one on the browser based upon some JavaScript code, and another one on the Meshery server. So if I, and this thing is tracking each pixel of my mouse, and it's just running all over time. So I can't uh, I can't connect this deployment to the service or to the namespace because of the client-side evaluation engine. But as soon as I try to do the same thing with service, so it will, if I'm in range of the deployment, it will form a relationship with the deployment. And after that, we have formed a relationship. Then another, till now, no Meshery server was running. And now this thing got ran again, and that's the same round trip happened. This design document sent to Meshery server, and yeah. So currently, that's how what we have in the Meshery server, and that's how policies are enforced in evaluating and forming relationships in designs. But Guanming, Avid, and Lead, they are working around to porting this system to native Golang. And so there's a nice document over here prepared by Guanming. So you can also go through it. So the reason why we are porting from open policy agent to native Golang when evaluating relationships is that first point is performance. So since OPA runtime incurs significant overhead, and that's also adds another layer, but native Golang eliminates the interpretation layer entirely. So that's quite fast and way too fast. So and also the Rego policies, the code that have been written around enforcing these rules. So they are split up across multiple files, and whenever all of them they get merged, so there's no order of execution over there. So for example, if we go to some of the policies over here, like evaluation.rego, so all of these gets so there's no execution order in it whenever they are merged. And you can check some of the Rego policies over here that have been written in the Mishri code. But coming back to, so it adds more maintainability to have all these rules defined in multiple files, and uh, Golang, native Golang completely removes entirely this thing by having three things like validation, identify, and action. So it checks existing relationships and approve the valid ones and delete the stale ones. Then another phase is to identify, scan component pairs against registered definitions, what we have registered, and create new relationships where selectors match. And similarly, when you're syncing, that's the action phase. So also the native Golang is much more portable, and since we are currently having two engines, so it's we want to deduplicate that sort of thing, and we would be having ideal scenario would be to having one evaluation engine that we will be reusing, and like each of the clients would be querying the same evaluation engine. Either it would be Meshery CTL or the client would be UI. So yeah, and it also has some of the test over here. So as you can see, this is the performance overview. So across 312 designs with relationships, 161 designs, that is 42% of them timed out under OPA. So when they were using OPA. So due to timeout, they got forced stopped. And but the Go engine handles them all in milliseconds. So as you can see, it's way too fast than using another interpretation layer as OPA. And these are some of the performance tests and known bugs that we have in Open Policy Agent. For example, the Open Policy Agent has a legacy prepass, and to put this simply, so it doesn't detect all of the relationships, and it deletes some of the valid ones due to the legacy flow processes only inventory subtype relationships. So that's the reason for it. And that's one of the bugs that we have in OPA. And so you can go through this document. There's a lot of effort being put up over here. But yeah, talking about OPA, so uh, these policies just do more than that rather than defining relationships and designs. So we'll be continuing using Open Policy Agent as well. But for evaluation, the native Golang ones outperforms what OPA has. And in future, we'll be also we may be having like something like a dynamic loading of each of the policies. For example, if I want to load like 1,000 relationships over here, so the how scalable it is, and there's some questions need to be answered. So a similar topic was covered uh, the in the one of the Meshery development meetings, I believe last to last week. So yeah, and so I'll be dropping this link to this document. So if you want to contribute, you can check this contribution guide of how you can contribute to policies, and you can keep track of the latest work being done around this. And I believe there's one more document in about policies. So this is the architecture of the policy evaluation and how we have context-aware relationships. And in future, like for example, we'd be having some WebAssembly that would be having the same evaluation engine or something. But you can also use Meshery CLI. I believe this command is outdated. Meshery policy list. So
Yeah, it's
there's
not there.
yeah yeah. So you can check around this document, and yeah. So that's all related to policies. I think we can move on to the practice questions.
Before that, I wanted to clarify one thing.
Mm,
Earlier, while I was actually going through the models, I accidentally told that it's not possible to delete a model, but I noticed that there was actually work which was done in Meshery, and this actually merged with the master branch right now. Last month, it was actually done to include a feature to delete a model also. But if you look at the UI in Canvas, we don't have that facility. So I'm not sure, like, if you want to actually delete that, how exactly it will be actually handled at the UI end. So that's just one clarification which I wanted to tell. Also, the documentation needs to be updated um, related to that. Yeah.
Yeah, thanks for mentioning that up. Uh, I believe that someone can help over there. So yeah, Yash is also tracking this area uh, quite often. So Yash, would you like to add anything if we have missed anything or just have some thoughts around it?
Thanks, Ronak. Thanks, Kavita. Nice information. About importing models in the Meshery Playground UI and then deleting them. Actually, what we have to do right now is to, if you have imported any model in Meshery UI, then you have to flush your local database if you want to delete it, because there is no any other way to delete it till the date. So I remember when I imported a wrong model there, so I had to flush my local database. So this is the only way currently if you want to remove your imported model in Meshery UI. And if you're registering it in Meshery, then definitely there is no any other way rather than like flushing your local database. And if you're flushing your local database, then all of your designs and all of the things you have stored there, they will be deleted.
How to handle it when we are using the playground then, and then using layer 5 IO instead of any local provider?
I think if you are importing then it on Meshery playground, then there is no way for any other than the administrators to delete that model.
Yeah, somebody who has
Yeah.
actually right access
Yes,
to
yes.
the database only
Administrators
can
can
help.
do
Yeah.
that, but no, other peoples can delete any model, because if there is any option for that, then it will be chaotic. And that's why we don't have that option there yet. But if you are doing it on your account or local, you can just flush your database.
So I have a follow-up question, like because this deletion in Metricity was actually done relatively, uh,
Mm.
I mean recently. I think it's just 2 or 3 weeks back. I mean, there is kind of inconsistency when you have the capability in mesh CTL alone and not inside the canvas, right? The UI, where we are actually having create and import models, but there is no delete model. So, I mean, have we actually created it? Have we actually given any thoughts on how to have that capability if required? Or is it a cautious decision to exclude that so that production is not affected by somebody clicking on delete by mistake?
Yeah, definitely. It is currently a cautious decision. It is intentional for now, because we are still evolving, and that's why we need a better architecture for all those things to make sure that we won't be having any chaos or anything else. But yes, the work is going on it. As you can see, Gonmeng, Abid, and Lee are essentially working on it while I'm focusing on relationships and models to generate them. So yeah, definitely there is efforts are definitely going on it. So to add this functionality.
Nice. Thank you,
Yeah.
Yash.
Yeah. Thanks, Yash. I think we can now move on to some of the practice questions.
Yeah, and one more suggestion, if you wanted to contribute to the models currently as a contributor, what you can do is use a spreadsheet. And if you are wanted to create models to the spreadsheet, actually you need a Google API ID, so that you need to have register that spreadsheet on GCP for to get that ID. But we have facilitated that now you can actually use CSV to generate relationships, models, or components. So in the spreadsheet, what you have to do is just make a local copy of that spreadsheet, because that spreadsheet is not accessible for anyone else. It is not editable. You can just view it. So you need to make a copy of that spreadsheet and then download it as a .csv on your local, and then you can use Meshery raise to generate and the flags of files to point out to those locally saved CSV files. You can generate the models or components of specific relationships by giving flag to that specific model. So that's a way to contribute to the models, I will say currently, because as you can't import model to the UI directly if you're making any mistake, and then you can
Okay.
raise a PR for that. Yeah.
Yeah, I had one more question about the source URL that you actually have in the spreadsheet.
Yeah.
Um, that I mean, those should be actually there for a particular CRD that is actually valid and then available in GitHub or Artifact Hub, right? So how do
Yeah.
we actually, uh, get these source URLs in the first place? Um,
Source URLs for I mean, are you talking about like having those source URLs, right?
yeah, I mean,
Yeah.
I just actually
Where to
just
find them?
share um, let me just share the screen so that we are in
Sure,
the
sure,
same page. Yeah,
sure.
that will make it easier for others also.
Yeah.
Yes, this is actually something relatively new, and this spreadsheet existed before I joined. That's the reason why
Yeah.
I have this question. So
Okay.
if you look at each of them, you have Artifact Hub and then GitHub.
Yeah.
In the documentation also, we just mentioned that you should actually be pointing to a particular CRD,
Yeah.
valid CRD only. So, but
Yeah.
how do you actually source all these things like model display name and the source URLs? Like, um, how do we scan and then create a new one if required, which is available and unique?
If you're looking at this spreadsheet, then if you are using this spreadsheet with Google APIs, then take a look at this spreadsheet. There are so many fields that can't be human field. So actually there is a Go code which is actually monitoring this spreadsheet. If you are using that spreadsheet ID, when maintainers are using that, there's a functionality that for the existing relationships, components, or models, that is tracking of whatever we are having and what new we are trying to define. And when you run that command, so whatever file is generated, if I'm noticing when you are using the CLI, then it is generating files using random names, right? So those names are automatically getting registered in this spreadsheet. And about the source, actually we have that in our backend logic, so that we can actually iterate on those source and then we can get the whatever we need from them, because as we saw that in those particular CRDs we have all the components defined. So that's how actually we get from them. And those CRDs, for example, and yeah, there is one more twist. If you are looking at the AWS CRDs, then AWS is using ACK controller for those models. And if you are looking at the AWS CRDs, then is having CRD, individual CRD for each and every component or model. For example, for if you are going for AWS, then for AWS S3 it is having AWS S3 CRDs. For AWS EC2 it is having different. But if you are going for the Azure thing, then Azure is having only a single link for each and every component of it. So that's why, and as you have asked me that question, for Azure, it is currently like we have enabled some of the things, for example, versioning and horizontal vertical grouping, for example. Okay, that's a high level topic, but yeah, those things for the AWS and Azure are making differences, and we are actually ongoing. There are actually ongoing efforts on this thing also, because when it's about Azure, we have to like iterate over 150 plus components time to time. So this is how actually CRDs are working. And why I told this thing is because I wanted to highlight a difference that actually when we are pointing to those CRDs, for example, if you are pointing to Kubernetes or AWS, then it will only iterate over that particular CRD. And when we are going for the Azure, for example, it will go that single CRD which is having listed, yes, this one. So which is having listed all this 150 components. So it will iterate every component one by one, like 150 times. And that's why
Oh,
if you're looking at the time complexities and all those things, then Azure takes time to generate the models. So this is
okay.
how we actually iterate on those things. And those CRDs are actually stored on the GitHub. For example, for cert manager, we have it on uh, cert manager repository. As you can see, I have pasted a link in GitHub. And for
Yeah.
AWS, it is ACK controller, and Azure, it is ASO controller.
Hmm.
Yeah.
Okay. So then this is one question which I had while looking at it, like why exactly you have
Yes, it
different
is.
types of
Yeah.
models and then the same URL for all of them. That's
Yeah.
one thing which I wanted to ask somebody who has been working with the models here. So yeah, thanks for
And
clarifying
this is
that.
our
It's
GSOC project also to make sure that we will be having ASO support. So yeah,
hmm.
there will be high scope to work on these issues also.
Yes. We are over time. So what do you prefer? Just run through the questions or have it in
How many questions are there?
20 questions are there. Yeah, it depends on what the participants wants because it's Friday night for most of them. Yeah, um, and that's why I
Yeah,
had this question.
I think then we can just post that on the discussion forum. And
Yeah,
if not,
it's better to post in the discussion forum. Yeah,
yeah, let's go for next week. Okay.
yeah, sure. Okay.
All right. So we are over time, and thanks, Yash, for sharing that wonderful piece of information.
Yeah, and
So,
one more thing I would like to add is currently Meshery is having 391 integrations in total, and we are having
mm,
so many components and all those things. But to add the relationships, we have to make efforts for that. And there is a huge gap to fill in, definitely it is highly encouraged all of you to contribute in the relationships. And if you want to contribute in the Meshery, then I will encourage to start with the relationships, because it doesn't it doesn't consist of code blocks. You just have to write some JSON files, and yeah, you can start contributing with models, relationships and components. Yeah, thanks.
all right. That's really wonderful. So, do you have anything else, Yash, Kavita?
I don't have anything from my end.
Yeah.
All right. So we'll be seeing you on the next week. Till then, hope you enjoyed the session. Thanks for joining, everyone. Have a great weekend. Bye, everyone.
Yeah, thanks everyone, and bye.